Good day, Computer Science today. In the last lecture, we talked about how games are structured and what the purpose of games are. More specifically, we focused on the three stages of how games are developed, that you need to have a start for your game, you need to have a gameplay loop, and then you need to have an end state that is reached by the player. So before I talk about some advanced JavaFX features and the provided files that were meant for your PracX but are now going to be released to you in the form of a bonus practical for any of you who want to practice actual development of a game in the confines of this course, or outside of this course if you want to, we are going to look at some examples. So I've developed here two games, a dungeon crawling turn-based kind of game that is going to be of the type that we discussed as the first type of game, that is driven by player interaction, that nothing happens until the player does something. The second example is going to be that of a shooter where the game is going to continue even if the player does nothing. So let's dive in and have a look at this first game. So if we have a look at this game, we are going to be presented with a black screen. So I'm just going to zoom in here to make it a little more apparent what I am doing. Just waiting for the zoom. And we can magnify. Okay, so here we have a game world. And now if I move the character using my keys on my keyboard, there we go. Let's just minimize that. You'll now see that I have a little game character in this world. And now nothing is happening while I'm talking to you. But if I were to press, say, my W key, I can move up and expose more of the game world. S to move down, A to move about, and you'll see I'm now navigating the game world one turn at a time. But now you see there's this dark pit over here, which I can avoid, or if I'm clumsy enough, I can step into and lose the game. So as you can see in this application, what is happening is that the game is waiting for the player to do something. So that is going to be the loop of the gameplay. We are waiting for the player to make their move, and then something happens. So naturally, the start state for a game like this is going to be, we need to set up the world. So in this case, I've loaded up an entire world from a text file and then populated it and drawn some sprites that are then rendered onto the screen using a visitor. So in this case, if you can see, here's an enemy, and you will note that I have some game mechanics, that I have health. So if I were to walk into this enemy, I have now defeated the enemy, but I have taken some damage. So that is one of the game mechanics that I have developed here for this particular game. Now, I can begin traversing the dungeon, and I'll note that now there's a locked door over here, which I cannot go through. So naturally, when something's locked, you'd need to find a key for it. So in this case, I'm going to now continue navigating through this dungeon until I find, oh, look, a chest. So if I were to interact with the chest, I will now see at the top of my screen, I have a key, which means I should be able to open the door. I'm going to avoid this enemy because I know what happens when I interact with enemies. And now I've unlocked the door and can begin moving through the world. Oh, there's a spike trap. Let's hastily step on it, and you'll note that I've also lost some more health. So traps are also one of the mechanics. So if we were to just summarize what these mechanics are, the mechanics that I've built into the game so far is you're going to navigate your character throughout this maze of a dungeon. You need to find keys and avoid traps. So here I find a key. I can now use it to navigate through the dungeon and unlock doors in order to find things. So you'll note that this is a very bare bones kind of game, and the ultimate goal of this is that you want to navigate all the way to the end of the dungeon to escape. So that is the final end state of this particular game. You have escaped the dungeon, but in order to get to this end state, you need to make use of the game mechanics such as the health and the keys in order to get through it. So when you design your game, you need to design your game mechanics in such a way that they lend well to helping the player or hindering the player in achieving the goal. Of course, it's not fun if you have a game where the player just walks straight to the end and finishes the game. You want them to be given some kind of a challenge or some kind of mechanics that will make their playtime a little bit more fun while they are using your game mechanics to play the game. So as you can see by this particular game, it is required of the player to navigate the maze and then interact with the chests to get the keys to unlock the doors while avoiding the traps, pitfalls, and enemies, which would reduce their life total and prevent them from achieving their end goal. But if their health reaches 0 or they fall into a pit, they have also reached an end state. So if I were to go and play the game again and now navigate, and I've already shown you how you fall into the pit, that is one of the end states of this game. If I walk over the trap, I get less health. If I walk over the trap again, I get less health. If I walk over it a third time, I die. Therefore, I have reached the end state. So there's 3 end states in this game. 1, you successfully exit the dungeon. 2, you run out of health by interacting with enemies or traps. Or 3, you fall into a pit and end the game that way. So that is how you would design a player-driven game, is you identify what you want as your end goal or your end state to be, and then start building mechanics that lend well to that. Let's look at a different game now that doesn't require the user to input every key press at a time. So I'm going to open up a different game now, which is going to be a space shooter game, also developed in JavaFX. So over here we have a space shooter game where now I am the player, and you will note that I'm flying around in my little spaceship by pressing my keys, and you will note that I have a shield, but if I let the enemy hit me, oh, I've lost my shield, and also I have a health bar up here at the top left of the screen. So if I take damage by getting hit by things, I'll eventually run out of health and it'll be a game over. So that is the end state of this game. Well, it is one of the end states of this game. But you will note that if I play the game and I do nothing, I don't interact at all, the game continues playing and I reach the end state. Because we are now not building a game here that is based on player-driven interaction. It is continuous interaction because the game is going to run regardless of what the player does. It is up to the player to now interact with and figure out what the mechanics are to play. So as you can see here, we have a boss. And if I click my mouse, I shoot the boss. And you'll notice his health bar below him goes down. But also you'll note that the boss spawns off lots of little enemy flying saucers that come at me. But you'll also note another added layer of complexity, that the boss is shooting at me. So these are all mechanics that I, as the player, need to interact with. So I need to reach the end state of this game by A, not dying, B, by shooting the enemies, and then hopefully I'll get to a point where I can maybe use a special ability or 2 to shoot lots of things at the enemy, and then reach a point where, let's just finish this boss off. We have victory. We have defeated the boss, and now we have won the game. Okay, so that's one of the 2 end states that we have in this particular game. So in this game, you can either die by getting shot or impacted by the little flying saucers, and your health at the top left here is reduced to 0. Alternatively, you can defeat the boss flying saucer and achieve victory. The mechanics that we have got to interact with are the ability to shoot, the ability to launch our special ability that will launch a lot of other bombs, laser shots, if you will. And we have the mechanic of health, where if our health reaches 0, we lose. There is enemy health, where the enemy health is reduced by us attacking them. And we have other things like power-ups to get our special abilities and the shield power-up. So you will also, if we run the game once more, if I don't focus on the boss, but instead focus on just shooting his little minions, eventually one of them will drop some little health power-ups. There's also a power-up that gives me additional special shots, and one that gives me shields. Let's see if we can get those to spawn. They're all randomized, so that is a form of mechanic. So at this point, I'm interacting with the little enemy units to see if they will drop me some power-ups that I can then use to help aid me in defeating the boss. So if my health gets low, I can pick up a health power-up, which will increase my health. So if I take some damage, oh, I took too much damage there. So this one's a little bit more skill intensive. Okay, so let's see if we can get some more power-ups quickly to demonstrate their ability on affecting game mechanics. So let's just see. There's a very low chance. Okay, so there's a shield. So there I've lost my shield. If I were to now pick up the shield, you see I picked it up, but then I got hit again, so I lost the shield. So the shield just gives you one hit of protection from the enemy. So these are all forms of game mechanic that I've built as a means to help make the fight a little bit easier against this boss. Because this boss does hit you for a lot of damage, so you can lose your health very quickly if you take lots of hits. So you've got to keep moving, and you've got to keep hitting the enemy, and then you'll probably eventually reach the game over if you got hit too many times, or you'll defeat the boss and win. I've just accidentally maximized that. Okay, so what are we dealing with over here? We're dealing with two different types of game. The first one I showed you was player interaction driven, and the other was continuous. Now, for most of you, you should be aware of how you can produce a game that is player driven, that you wait and you stop the game waiting for the interaction of the player in order to then compute your game logic, check to see if your game state has reached its end state, and then continue again. But you might not be aware of how you can actually interact with a player on a continuous basis. Okay, let's close these two game projects and let's look at another project that I will provide to you on Eve so that you can tinker with and make your own games. So what I have here is a project that is made up of the provided files that would have been made available to you as a part of your PracX. But seeing as we are no longer able to do PracX, we're going to do this as a form of bonus practical where you can create a very basic game using the provided files. You'll note that there's a lot of files given to you here. Let's start at the top and just go through them one by one. You have the main of the program. Now, the main of the program is going to be your normal entry points. It's a JavaFX application because we're going to be using some cool stuff in one of these other classes to actually do a continuous timer. You have an iRenderable, which you should note is for your visitor design pattern. There's an iRender visitor, which is going to then be the interface defining your visit operations for your visitor. And then finally, we gave you a game object visitor, a render game object visitor. Now this here has already got a lot of stuff set up inside of it, that it's already got the graphics context that can be passed to it, and then it's got to-dos here for all the render methods for all your different game objects. Because if you were to create the one game that I made, you'd have different game objects to the space shooter, for instance. So this is more of a framework that is designed to get you started in developing a game without having to do all the very nitty-gritty base boilerplate code. There's also a game file handler, which just was there because there was a requirement for your PracX that you had to interact with files. So you would have to interact with, say, a text file to maybe load your level, and a binary file for you to then write all of your game state out and maybe do a save game or something like that. There's also in the model package here, a game object, which is the base object for all of your game objects. So every game object you would create in PracX would be derived from your game object, which then implements iRenderable so it can be rendered onto the canvas. This most notably has a location, a 2D point location, which is an XY coordinate that is used to then render the object onto a game canvas. And you'll note there's a bunch of accessor and mutator methods here that enable you to manipulate the location of the game object. So all this game object is really meant to do is give you the location of where the game object is in the world. So you would then inherit from this game object to create your own custom game object, say a player object, an enemy object, a projectile object, that are all going to have a location that they need to be drawn in the world, and thus will inherit from this game object, but also implement the iRenderable interface, which there's a note at the bottom here. It says in your derived class, you need to actually implement the accept method so that the visitor can visit this object. To make your life a little bit easier, we provided you with a generic container called a game object container that stores any object that extends from game object. So your player can be stored in this container along with all of your enemies and all of your projectiles and all of your other game objects, so that you can pass this entire game object container to your canvas and then have it rendered. Speaking of your game canvas, you'll note that your game canvas, we've given you a very basic canvas here, which extends a canvas, which is a JavaFX canvas. And then we've got over here already an instance of your visitor design pattern. You will then need to build your game logic of what you want to store here and have your accessors and mutators. So what I would suggest you do here is store a game object container instance here, which you then just pass from your main game pane into it, and then call the redraw canvas method code. So your redraw canvas is then going to be responsible for setting up your graphics context, and then iterating through all of your game objects and getting the visitor to visit each of them. Okay, so then that brings us to what's going to host the game canvas, and that is going to be the game pane. So the game pane is going to have the game canvas, and here's where the advanced JavaFX stuff really comes in with an animation timer. Now, there's going to be a constructor for your game pane that is going to then create and store your canvas, because your game canvas is where you're going to draw things, but the game pane is where you're going to handle your game logic. Now, there's a method here called setup event listeners, and this is provided, which will make use of this keyboard and mouse buffer to actually intercept keyboard and mouse presses and store them for you so you can interact with your game. This isn't required. You can see here it's put in the optional section. If you would prefer to make a game in the format of the first game where you wait for the user to press a key instead, you can do so without this keyboard buffer. But this is already set up in such a way that if you have a look down here, we go a little bit further down to the bottom, here's the setup event listeners. Now what this does is it just sets up the event handler that will be responsible for doing particular things, like setting an on-key pressed event, an on-key released event, mouse moves, mouse presses, etc. And what this will do is we'll offload this functionality to our key buffer, the KM buffer, which is a big class that you don't really need to know how it works unless you want to. I'll provide you with the code in the upload so that you can have a look if you want to understand how it works. But the idea is this is going to store the information about what keys are pressed or not pressed at any given time. So it gives you a bit set which correlates to all the keys that are on your keyboard, and then they're just going to be set or not set. So if a key is pressed, it'll be true. If it's not pressed, it'll be false. And you can just check these at any time. There's also going to be a bunch of variables relating to the mouse. So is the mouse in the window? Is it not in the window? Is the left mouse, right mouse, middle mouse pressed? And what is the location within various points of the JavaFX application hierarchy? So you'll note that what's going to happen is when you press a key, it's going to just set the value to true. When it releases a key, it'll set it to false. Now I'll show you how this works in a moment, but let's quickly go back to the game pane and talk about the all-important new JavaFX toy that we have to play with. So once we've created our game pane and set up our event listeners, we're now going to talk about our game timer, which is going to be an animation timer. Now, an animation timer is a way that you can run game logic at set intervals. So let's say you want to run the game and compute your game logic at set intervals. This can be done using an animation timer. So this is different to the timeline that we talked about in the previous lecture tutorial. In the previous lecture tutorial, it was a timeline that we would set keyframes on and then run the entirety of the timeline and animate everything in one shot. You can't do that with a game because you don't know what the player is going to do. The player might do something, they might not do something, they might do something completely different. So you don't know what to do ahead of time, so you can't use a timeline. So instead, we're going to use an animation timer. And when you create an animation timer, it's going to have a handle method. And this handle method gets called at a fixed interval. So what this means is you can execute this code at set intervals a few times a second, which enables you to move your objects around, check for player input, and do all the things that relate to your game logic. Now, what I've done here is I've requested focus on this panel. This is very important because we've set up the keyboard and mouse listener, which is going to need to intercept our keyboard and mouse presses. So this will ensure that this game panel, or game pane rather, is going to get the keyboard and mouse presses that are then going to be stored in our keyboard and mouse buffer. So once we've requested focus, we can do all sorts of things. Like what I've done here is I've given you some hints about how to use the animation timer, and I've given you some resources you can go read to see how to use the animation timer. But ultimately, what you're going to do is you're going to want to do your game logic inside this handle method. Now, in this case, I'm doing things like checking to see if the up key is pressed. So if you want to move your player around with your directional keys, you can then check to see if a particular key is pressed. So here, kmbuffer.isKeyPressed. Because we registered the keyboard and mouse buffer as the handler or the buffer for our keyboard and mouse presses, we can now check to see if things are actually being pressed when this code runs. So we can check to see if the up arrow is pressed by using the keycode.up and checking is key pressed. This will output the result of that. Whereas if we were to run the mouse buffer, we could check to see here if the mouse is in the window or not. And then we could actually check to see what its relative location is to a particular node. So in this case, I'm going to get mouse node location. This will be relative to whatever the focus node is going to be. So what we can do is we can get the X location and display that, and we can get the Y location and display that. So remember, those are all going to be 2D points, which is going to be an X and a Y location. We can also do things like check to see if the mouse button is pressed. And then we can do something if the mouse button is pressed, like maybe create a new projectile and send it at the player, or send it from the player to a particular enemy. Now, the last thing we're going to want to do is call our redraw canvas method, and once we have updated it with the game object. So if you've created any new game objects, you'll add it to your game object container, send it to your canvas, call redraw canvas. This would be exactly the same kind of methodology you'd be using in your practicals to draw your objects in the world, except now the objects are being continuously updated thanks to the handle method of the animation timer. Okay, the last thing we need to do is then start the game timer and add the canvas to be the child of this particular game pane. Okay, so that means we just need to then pass the game object to the child node, the canvas, like you have been doing in your practicals anyway, and then getting it to redraw the canvas. So either you can manually call redraw canvas, or inside your canvas, you can set up a method, say, to get the game objects in the game object container and automatically call redraw canvas once they get updated. Entirely up to you. So maybe the keyboard and mouse inputs would make a little bit more sense if we were to show you how you could get a very basic set of interactions up and running inside your game. So let's head on over to the main of the program and have a look at what's there. So inside the main of the program, you will note that there's just some Java doc comments where it's asking you to input some stuff there so you can make some changes. But it's a JavaFX application. We know how to do this. The first thing we're going to do is we're going to go inside of our main and launch our application. Oh, Rx. There we go. Now what that will do is it'll call our start method. And what do we do inside of our start method? We create our game pane and show the window. So in order to do that, let's do the following. So let's create an int width and int height. Give us a reasonable sized game window there. And let's now create our scene graph and a scene and load it onto the stage. So let's create our root node as the game pane, because the game pane is going to be where we're going to handle all of our game logic. Okay, and we should have then imported that game pane from our UI package. And now we can do things like go root.set preferred size, and we can pass in the width and the height just to make sure that our game pane is the correct size. And then what we can do is we can create our scene and put the root node as the root of the scene graph and put our width and our height there so that we have a scene that is the correct size to fit our game pane. Finally, we're going to take our primary stage and we are going to set the scene to be our scene. Lastly, we can then go .show. Okay, so what we should have now is we should have a game window pop up. And you'll note at the bottom left of the screen here that this is flickering. And the reason that is flickering is because the game animation timer is running continuously. Even though we're not displaying anything here, it's just checking for our input. So this is going to be a good starting point if you want to start making a game that runs on a continuous basis as opposed to a basis where you wait for the player. So you'll notice we've got a whole bunch of things that we are checking. These are the things I showed you inside the game pane that shows, is the up arrow pressed? Is the left mouse button pressed? Is the mouse actually in the window? You see the mouse is not in the window, whereas now it is in the window. Not in the window, in the window. And you'll also note that the mouse location relative to the canvas is also going to update as I move the mouse around. So it's keeping track of where the location of the mouse is. So if I wanted to like maybe spawn an enemy where I click, I could click and then you'll note there that it checks to see if the left mouse button is actually pressed. So left mouse button pressed, false, true. Now it's saying that the mouse button is pressed. So I could do things like maybe shoot or spawn some enemies or place a building or do whatever we want to do as part of our game mechanics here. The last thing we can do is check for keyboard presses. So note up arrow is pressed, false. If I press the key, it changes to true. So now it's checking for that particular key press for the up. So maybe up is move the player up. Then what you can do is you can have some more. Let's quickly go into the game pane where I've got the keyboard and mouse event listener happening. Like over here where it's checking for up, if the key is up is pressed, we can move the player object one pixel up or something like that. Whereas now we can add different ones of these for down, left, and right to check to see if we want to move the player down, left, or right. So now we could actually just copy one of these and let's just see if the, say, down arrow is pressed and we could go down and run the program again And now it will be outputting is the up or down. So now down, true, up, true, down, true, down, false, up, true, both. So because it's done in the form of a buffer, we can actually have multiple key presses be handled and triggered simultaneously. So this is the advantage of having a buffer as opposed to just checking things individually one at a time. So the player could move up, they could move down, they could try and do both and stand still if you wanted to. So this will all depend on what your game logic is going to be. So when it comes to things like the animation timer and this entire handle method, this handle method in JavaFX is where you're going to want to do your game logic. So that's going to involve things like moving your player, checking to see if the mouse is pressed, where it is pressed, so that you can do whatever your game mechanic is that you require for your player to then do the gameplay loop. So if you didn't already notice, this entire handle method functions very much like a continuous loop, that it is going to execute continuously until you tell it to stop, so you reach your end game state. So in this case, you can think about this handle method as like a while true loop that can be broken out of by the JavaFX application. So what you want to do in here is do all of your game logic, like intercepting the key presses from the key buffer, doing some logic with that, say moving your player, checking over here what your end state is going to be. Has the player maybe fallen into a pit? Check to see if the player is at the same location as a pit. If they are at the same location as a pit, then you need to update your game state to reflect the changes that the player has made by moving. Alternatively, let's say you have a game mechanic of health. If your health reaches 0 because you've been hit by too many bullets, so your bullet has intersected with your player, or they exist at the same location, then you need to reduce the player's health. But if the player's health reaches 0, they have reached an end game state and you should end the game. So all of this will be dependent on how you utilize this animation timer's handle method to interact with your game mechanics to reach one of your end states, whether it be victory, loss, defeat, whatever it is, depends on your game. Okay, ladies and gentlemen, this code is going to be posted on Eve for you to play with. It is going to also form part of one of your bonus practicals. So if you want to get started by having a look around the game code, implementing the things I have just done to intercept some mouse presses, maybe create a game player object, give it a blue block or something, and move it around the screen, you can do so. Also, the bonus prac is going to be worth a lot of marks. So if you want to do this game bonus prac, it will be worth your time. And for those of you who just want to interact with JavaFX and have a nice quick route to start developing a game in JavaFX, you've already seen what is possible. I created a game which had some hand-drawn sprites, which you can then render on the screen. I also created a game where I used game objects like squares and circles to actually create little guns and create shields and those kind of things. So all of these things are available to you in JavaFX if you want to create your own basic game. What you're in essence doing is building the game logic and the game's graphical engine yourself by doing low-level rendering. So you're in essence creating your own game engine by creating your visitor and having it visit all your game objects to accumulate the game state on the screen. You are building a very low-level game engine that is going to handle graphics and game logic, and we've provided you with the keyboard and mouse buffer to handle inputs to the program. So you have all the tools you need to create your own very basic game, and I wish you luck with that, and I hope you have many hours of fun playing with it. Just don't neglect to study for your semester test coming up. Thank you, ladies and gentlemen. Until the next lecture,